Right, so at page 50, sorry, not far yet. Page 17.
In the notes.
In your notes, yes. Right, inequations, or inequality they're also called. Right, so when we solve an equation, we have a set number 1 or 2 solutions depending on the format of the equation. When we have an inequality, it means we're going to have an infinite number solution. Okay, that's the definition of it. Right, so you should all know your arrows and the bar underneath. And then we're going to look at some graphing today as well. Okay, so to solve an inequation or inequality, they're also called, we do it in the same way as we do an equation. The only difference is when we multiply or divide by a negative number, or when we take reciprocals of both sides, the sign changes. Right, so for example, that's all I'm going to do today. Solve the following and graph the solutions on separate number lines. And A, Emily, can you turn the lights on for me, please? Can you turn the lights on? Right. 6x is greater than 18. Right, so we use our equation skills to solve for these inequalities. Right, so this is an equal sign, 6x equals 18. Right, so we're multiplying x by 3. So to solve, I divide by 6 because that's the opposite to multiplying by 6. Right, so x is greater than 18 divided by 6, which is 3. Right, so any number that's greater than 3 will satisfy the original inequality. So, x equals 4.
What circumstances did a heat flip?
I'll show you in the next example, okay? Right, so a number that's greater than 3, let's set x equals 4 into the original inequality. So we're going to set it back into 6x is greater than 18. So 6 lots of 4 greater than 18. So 24 greater than 18, yes? Alright, so another number that's greater than 3, 10. Really? Alright, so 6 lots of 10, is that greater than 18? Okay, so 6 lots of 10, which is 60, greater than 18, so the number 60 greater than 18, yes. Okay, so what this is trying to get at is there's an infinite numbers solution for our inequality. Okay, the equation will be 1 or 2 typically, or 0, that can happen. Inequality, any number that's greater than 3 works. Alright, so that second part of the question asks you to graph it on any number line. Right, so you need a ruler, or you really just need a straight edge. Okay. Okay, so what's that? It's about 10 centimetre line will do. Congratulations, the image has just made an appearance in the video. Okay, so when we do our number line, so you're going to put that number 3 in the middle, okay, or more or less the middle. Okay, so have equal increments. That'll do. Down as well. 3, 4, 5. Now ahead, because this is a line, not an interval. 2, 1, 0, -1, and of course the numbers keep going on that side as well. Right, we're good? Alright, so when we have x just greater than 3, so if it's strictly just greater than or less than, there's an open circle, okay? When it's also an equal component, there is a filled-in circle. Okay, so we want all the solutions which are greater than 3, so something like that. Okay, so that's how we graph on a number line. Okay, so make sure you use rulers or have a ruler. If you don't, please get one. You'll need it. And we should probably label this as x, so we're referring to all the x numbers. Right, B. Negative 5x, which is greater than or equal to 20. Right, so we solve the same as an equation. So I am multiplying x by -5. So I do the opposite to multiplying by -5 on both sides of the inequality sign. And this is the difference, okay? When you are multiplying or dividing by a negative number, or you take the reciprocal of both sides, so you would flip this over if you would have to. So for example, the variable's on the bottom. Okay, that's when you swap the sign of the inequality. So I'm dividing by a negative number. So when you multiply or divide by a negative number, the sign of the inequality swaps. Okay? So the solution is, in this case, x is less than or equal to -4. So any number that's less than or can be -4. Let's just show a couple. You don't need to do this, but I'm just highlighting what happened. So if x is -5, for example, back into the original inequality. So -5, so substituting back into the original question, lots of -5, it's got to be greater than or equal to 20. Alright, so negative times negative is positive, 5 times 5, which is 25, is greater than or equal to 20. Alright, and that's a true inequality. 25 is greater than or equal to 20. Alright, what happens if you go the other way? So the solution with x is less than or equal to -4. If you forget to change that sign, so if you said x is greater than or equal to -4, okay, so if you had x is a number that's greater than negative, let's do a positive number too. So -5 lots of 2 is greater than or equal to 20. So substituting 2 for x, The negative times positives are negatives. So negative 10 is greater than or equal to 20, and that's not a correct inequality because the original didn't suit the original inequality. Okay? So the sign changes when you're multiplying or dividing by a negative number, or if you take reciprocals of both sides. Okay, so typically you're more likely to see when you're multiplying and dividing by a negative number. Right, let's do a sketch. Graph the line. Oh, to the next page now. Okay, so about 9-10 centimetres will do. Put the number in the solution in the middle. So it was less than or equal to negative 4. Right, so negative 4, middle will be about there. Alright, so the last example we had just a greater than. Right, just greater than means an open circle than or equal to. Right, so in this case it'll be a built-in circle. Okay, so when there's an equal component as well, built-in circle. Right, then your ray just above the line. Of course, this is all my X value. Right, so you should have an alternating pen colour when you do the axes. Probably a good idea. And then your preferred pen colour can be the ray. Okay, something a bit different. 7, which is less than 4x plus 3, which is less than or equal to 15. Okay, something a little bit different. Okay, so basically what I need to achieve is get x by itself in this middle thing by doing the opposite operation. So, yep, so if we adjust to 4x plus 3 is less than or equal to 15, okay, so the first thing you need to do is undo that plus 3. So take away 3, take away 3, and take away 3. You've got 3 sides to consider because of the inequality. So you get 7, take away 3, 4, which is less than 4x, 3 take away 3 is 0, and then 15 take away 3. So less than or equal to 12. Right, so we want x by itself. So divide each of those 3 terms by 4. We'll all be able to hear this later. Okay, so when you have a 2 inequality, that they'll be facing this way, they should be facing this way, that means the x value's got to be between 1, not including 1, and also 3, but can include 3 because of the equal sign. Okay, that means our solution ranges from 1 to 3, and 3 is including. Right, so 10 centimetre interval. Right, so I want to put it in the middle best I can. Right, so I'm going to go 1, 2, 3. Okay, so it's mapping all our x solutions on the number line. Right, so we have between 1, not including 1. So at 1 it's got to be an open circle. And at 3 it'll be a closed-in circle because of the equal component. Okay? So if it's strictly greater than or less than open circle, if there's also an equal component, there's a closed circle. Alright, so where possible, you have to use a ruler. And yes, people like me will be nasty, so if you're not going to use a ruler, you're not going to get the marks. Okay? Yeah. Yeah, and I'm going to be nasty this way. Alright, so you are required to have, as well as a calculator, as a essential equipment, a ruler as well. Where we're not trying to defy the laws of physics in this classroom.
That's just ruler right here.
Alright, so rulers used where necessary. Okay, last one. Right, 6x take away 5 is less than 9x plus 11. Okay, so this looks like a 3-step equation. Right, so if I change that inequality sign to an equal sign, we're still using the same steps. Okay? Alright, so got variables on both sides. Step number 1, get the variable on the right over to the left. Okay, so that on the right hand side there are no variable terms. So variable terms are terms with letters. In there. Right, so on the second step, the constant number terms on the left hand side of the inequality sign gets moved over to the right. So negative 3x, which is less than 16. Right, and then get x by itself. Divide both sides by what you're multiplying by, including the sign. So x. Now, because I'm dividing by a negative number, means this direction swaps to point the other way. Okay, multiplying, dividing by a negative number, or if you are happening to take reciprocals of both sides, okay, the sign points the other way. 16 divided by 3, let's put it into, let's leave it. So, negative 16 over 3. Okay, so again, I haven't specified what format of your answer needs to be. Okay, so I can leave this improper. If you really wanted to, you could put it as a decimal or as a mix, but at this stage, not necessary. However, fractions do need to be in simplest form. Right, so there were common factors apart from 1. okay, you do need to break that down. Okay, that's a requirement for any fraction than any answers in any task.
You also don't think we should have changed the sign when you divided -9x?
Say it again. Here? No, because that's a subtraction.
Oh, that's right.
Yep. Okay, good question. I've seen people that would change that because they're doing a subtraction. Okay, so not when you're doing a subtraction, only when you're doing multiplication and division. Okay? Okay, if you don't ask questions, you don't know, don't you? Okay, so x is greater than -16/3. So the way I would graph that, right, so in the middle, -16/3. Right, so I'll do it like this. -15/3, -14/3, -13/3, -12/3, which is -4. Okay, and I probably should change this one to a -5. Bad. Okay, so if you do that, just write under it. Right, don't have to cross it out and do the whole thing again. Just write under it. So that part equals -5. Right, so -17/3, -18/3, which is -6, -19/3, -20/3. Okay, that's how I'd set it up. Okay, so instead of doing whole numbers and then putting a portion of a whole number in there, okay, I'd do it that way. Right, so it was greater than -16/3, just greater, so open circle, just above the line, and then your line is done just above the axis line, okay? So not including -16/3, but every single value number above it will also be a valid solution. Right, any other questions? Okay, so